Hello guys, so let's discuss the very common problem of the dynamic programming. So it is a very standard problem uh, when we study the dynamic programming. So it is called as the longest common subsequence problem. So we have given the two string and we have to find out the longest common subsequence possible for this two string. So what can be the possible subsequence here is one possible subsequence can be A and A. So we have A is common in both the string, or we can have A and B. So it can be AB, or we can have A also, or we can have A B and A B. So it can be A B, and then A B. Okay. So and so on. So we will find that we have only the longest common subsequence of length 4 only. So we have to find out the length of the longest common subsequence in this problem. So how would we solve this problem? So one way to solve this problem is to apply the brute force approach. So in brute force approach, what we can do is we can find out the all the subset or the subsequence possible for the both the string. So what will be the time complexity for generating the subsequence for the both the string is, so every letter here is having the two choices. Either it can be present in longest common subsequence or not. This letter also have the two choices. Either it can be present in the longest common subsequence or not. So every character is having the two choices. So if this is of length 6, then it will be become 2 raised to power 6. Or if we have x string of length n, then to generate the all the common subsequence will it will be generated in order of 2 raised to power n. And similarly for y, if y is of length m, then total longest total subsequence possible is 2 raised to power m. And then after finding all the subsequence, then we have to find out the common subsequence here. And in all the common subsequence, we have to find out the longest common subsequence. So this will be a very tedious task to solve this problem by using a brute force approach, because it is taking exponential time. So we want to avoid it. So what can be the better way to solve this is using the dynamic programming. Okay, so how we will apply the dynamic programming here is, so let's say for this example only, let me do indexing of this string 0 to 5, and this is also 0 to 5. Okay, so first of all, before coding the problem, we first try to find out that what is the changing parameter in this problem. So we want the longest length of the common subsequence. So we will iterate over the whole string in this problem. So let's say we have the function of the dynamic programming as f. Okay, and we have the index I and j, which will be initially, let's say we start from 5 at the end index. So it is 5 and 5. So we will check whether the uh, letter whether the letter which is present at the ith index and jth index in both the string is equal or not. If they are equal, then we can simply say that this will be my part of the longest common subsequence. Uh, for this problem, here a is present and here b is present. So this is not equal. So we have to drop one letter here. For example, if we have B A B B and then here we have A B B, then if we will check the longest common subsequence and we have the I and J here, so what we can do is we can check B is equals to the B. If B is equals to the B, then definitely I can include the b in my solution. Okay, and then can check the further string by decrementing the j ith in ith counter and jth counter, and then I will check that whether what will be the longest common subsequence for my left string. So the possible answer for is, we have find out the one letter common, so it will be 1 plus whatever is the answer for the left string, which is I minus 1 j minus 1. And if it is not equal, if the letter which are presented the ith index and jth index is not equal, so what we can do is either we have to decrement I, or I have to decrement j. So what can be the possible case here is, for example, here a and b is not equal. So if I decrement the jth counter, I will decrement jth counter, then I can find out the a and a as common. So or what I can do is, uh, what I can do is I can decrement the ith counter, and I can find out b and b as common. So I have to do only one thing. So what I will do is, our task is to maximize the longest common subsequence here. So I will say that I will find out the maximum of f I minus 1 and j, or f I j minus 1. So whichever function will give me the maximum answer, I will take it. So these are the two conditions. Okay, and if we make the tree for this problem, so what will be the tree here is, so let's say initially we are at the 5 and 5, so we will check whether a and b is equal. So a and b is not equal. So what we will do is, we will call the function for f 4 and 5 and f 5 and, then here we will check whether letter at fourth and fifth is equal. So we'll check letter at fourth and fifth is equal. If it is equal, then we will say 1 plus f, and we will decrement both the pointer, which will be 3 and 4. Okay, and similarly here we will check whether the letter at 5 and 4 is present or not. So at 5 we have a, and at 4 we have a, so it is matched. So it will be 1 plus, we will decrement both the pointers, so it will be 4 and 3. Okay, then we will check here whether letter at 3 and 4 is equal or not. So at 3 we have a, and at 4 we have a, so it is matched. Then we can simply say that 1 plus f 2 and 3. Okay, and similarly at here also, at 4 we have b, and at 3 we have b, so it is matched. So it will be 1 plus f 3 and 2. And then we will check element at 2 and 3. So we have 2 at a and b at 3, so it is not match. So we have to split the task in two parts. One will be 1 3, and one will be 2 and 2. Yeah, so here also at 3 and 2 we have at 3 we have a, and at 2 have b. So we will split our task in two function. So one will be f 2 2, and one will be f 3 1. So we can see that we have repeating sub problem here. Okay, and we are doing the same task at my smaller problem, because my first problem, initially my problem was f I j, but whenever I am finding the ith and jth index are equal, then what I'm doing is, I am making this problem into the smaller problem. Either I am doing fi minus 1 j, or I am doing fi j minus 1, or I am doing fi minus 1 j minus 1. So we have the same problem but with the different parameter. Here we have I and j, and here I have I minus 1 j, I j minus 1, I minus 1 j minus 1. So we have the overlapping subproblem as well as the optimal substructure. So how we will solve this using the dynamic programming? So let me try to let me make you understand by making the matrix. So let me use the different pen here. So we have the string, or I will copy this. Or let me write it down again. I have x as a b a b a, and y as b a b b a b. Okay. So let me make a matrix here. So it will be a b a b a, and here I have b a b b a b. Okay, and this is empty string, and this is empty. So or make me matrix properly. Okay, so this cell, what this cell is representing is that I have string 1 as empty and string 2 is also empty. So what is the possible longest common subsequence? So it will be 0. This is straightforward. And this cell is representing that I have string as empty and string 1 as a. So what will be the possible longest common subsequence for these two strings? It will be 0, because one of the string is empty. So it whole row is empty, and for this also whole row is empty because string 1 will be empty. And here we will check that our string is b and a, whether these two string is equal or not. So this letter is not equal. So what we were doing here is like one I was decreasing I, and another time I was decrementing j. So here also when we will decrement the I, so I will reach up here, then I will find out 0, and when I will decrement j, then I will end up here and I will find 0, and I will take the maximum of these two values. So here 0 will be the maximum because we have two 0 only. So here we have find out b, and b is equal, so b can be in our solution. So we what we will do is 1, you can see that 1 plus, we will check the string at I minus 1 position and j minus 1 position. So it will be 1 plus this value. So it will be 1. Okay. Similarly, here we check b and a. B and a is equal? No. So I will take maximum of these two values. It will be 1. Then I will check b and a is equal? No. So I will take maximum of these two values. It will be 1. Then I will check B and B is equal. Yes, B and B is equal. Then I will say 1 plus this value. It will be 1. So I will then I can check B and A is equal. So B and A is not equal. Then I will take the maximum of these two. It will be 1. And then here I will check A and A is equal. So A and A is equal. So it will be 1 plus this index, this value. So it will be 1. Then we'll check A and B is equal. No, it is not equal. So I will take maximum of these two value. It will be 1. Then I will check A and A is equal. So if it is equal, then 1 plus 1 is 2. Then A and A is equal, then it will be 1 plus 1 is equal to 2. Then I will say A and B is equal. It is not equal, so I will take maximum of these two, it will be 2. Then I will check A and A is equal. Yes, A is equal. So 1 plus 1 equals to 2. Then similarly, I will fill the table. So B and A is not equal, so it will be 1. B and B is equal, so it will be 2. B, A is not equal, so it will become 2. B and A is not equal, so it will become 2. Then B and B, so it will become 3. Because here we have 2 here, so 2 plus 1 will become 3. Then here B and A is not equal, so maximum will be 3. B and A is not equal, so it will be 1. B and B is equal, so it will become 2. Then B and A is not equal, so it will become 2. Then B and A is not equal, then B 2. Then B and B is equal, so 2 plus 1 is 3. Then B and A is not equal, so it will become 3. And then similarly A and A is equal, so it will become A and B 2, then A 3, A then 3, then A B 3, then A is equal, then 3 plus 1 4, then A and B is not equal, so it will be 1, A B and B is equal, so it will become 2, B and B equal, so 1 plus 1 will be 2. Okay, so and B and A is not equal, so it will become 3, become maximum of 2 and 3 is 3. So B and A is not equal, so it will be 3. B and B is equal, so 3 plus 1 is equal to 4. And B and A is not equal, so it will become 4. So we have our answer here. Because this index is only representing that I have string 1 as A, B, A, B, A, and string 2 as B, A, B, B, A, B. And what is our longest common subsequence? So 4 will be our answer. Okay. I hope this I hope that you understood the concept.